Hi, welcome to the Olympiad geometry. Let's continue our study on radical axis. Before we start, if you think this video would be helpful, please click the like button, comment, share the video, or subscribe the channel. Thank you. Let's see the problem. In triangle ABC, DE are points on ABAC respectively, and DE is in parallel with BC. Let BE be the diameter of circle O1, CD be the diameter of circle O2. Prove the altitude of ABC. So AH is the altitude of ABC, triangle ABC. The altitude of triangle ABC that passing through A is the radical axis of two circles. This is a very interesting problem because it actually requires us to relate the altitude to the radical axis. It looks like two different kind of thing. So I think the break point of this problem is that we need to understand where are O1, circle O1 and circle O2. How can we get the circle O1 and circle O2, right? Basically, we arbitrarily choose point D and E, but DE is in parallel with BC. That is a critical part, right? Because DE is in parallel with BC, that means the midpoint of BE, that is O1, right? The center of the circle O1, and the midpoint of CD, the circle O2, the center of the circle O2, which I mark it here as O2. If we connect O1 to O2, right, it's obvious that O1, O2 is in parallel with BC. And we already know that the radical axis is perpendicular with the center connection of two circles, right? Which means that the radical axis, let's just use L to represent for it, must be perpendicular with O1, O2. Okay, now we just have one problem. We either choose H or A. We just need to prove that the power of A to circle O1 and O2 are equal, or we choose the power of H to circle O1 or O2 and O2 are equal, right? Obviously, A would be easier to do because when we connect AO1, we know that, okay, let's see this one. So the power of A to circle O1, we can write it as AO1 square minus R1 square, which is O1B square, right? O1 or O1E square, whatever. O1E square. Right, that's a power from a certain point to a circle, right? We can represent it by this formula. And also, if we do it from H to circle O1, then it's HO1 square minus O1E square, right? And we know that HO1 is kind of difficult to calculate because H is a point that is related to the A, right? So why don't we just use A? Okay, now the problem is clear, is that we want to calculate the power of A to circle O1, and we want to calculate the power of A to circle O2, right? Which is AO2 squared minus O2D squared, right? We just need to prove that the power of A2 circle 1 equals to the power of A2 circle O2, right? That means A is on the radical axis, and since we already know that the radical axis is perpendicular with O1, O2, and AH is perpendicular with O1, O2, so we know that AH is a line of radical axis, right? Okay, how can we prove this? We just need to do a calculation, right? We already got AO1 here, O1 here. So what is AO1? Look at it here. AO1 squared. It just reminds us the Stewart theorem, right? If you don't remember the Stewart theorem, I just write it here. So now you can see it's really a powerful theorem, right? A, B, C, P. So we know that AP squared equals to AB squared times PC to BC plus AC squared times BP to BC minus, let's see this way, BC squared times PC to BC times BP to BC. Right, in the case that P is a midpoint of BC, we have AP squared equals to half of AB squared plus half of AC squared minus quarter of BC squared. Right, in the case that P is a midpoint, and it is a valid point for this this problem, because in the triangle ABE, O1 is a midpoint of BE, right? So AO1 can be written as half of AB squared, right, plus half of AE squared, right, and minus quarter of BE squared, right? BE is, okay, let me just write it here. So A equals to AB squared plus AE squared minus 1/4. So we need to think about how can we calculate the BE squared. We use cosine theorem. So BE squared equals to so BE squared equals to AB squared plus AE squared minus 2AB AE cosine angle BAE. Right? And that's for the AO1 square, right? And we want the AO1 square, we want to calculate AO1 square minus O1E square. And what is O1E square? O1E square equals to 1/4 of BE square, right? So, which means that AO1 square minus O1E square equals to half of AB square plus half of AE square minus, so look at here, it just turns this to be 2, right? So 1 by 2 AB square plus AE square minus 2AB AE cosine angle BAE, right? It equals to, these are cancelled, so it equals to ABAE cosine angle BAE, right? Similarly, we can get AO2 square minus O2D square, right? in the triangle ADC, we calculate AO2 first. A equals 2 half of AC squared plus half of AD squared minus 1/4 of DC squared minus O2D squared. O2D squared, that's also 1/4 of DC squared, right? So it equals 2 half of AC squared plus half of AD squared minus half of DC squared. DC squared equals 2 AD squared plus AC squared minus 2ADAC cosine angle DAC, right? So A equals 2 ADAC cosine angle DAC, right? Notice that cosine angle DAC, the angle DAC is angle EBAE, right? So ABAE and ADAC, because we already know that DE is in parallel with BC, so if we let we know that AD divided by AB equals 2 AE divided by AC, which means ADAC equals 2 ABAE, right? So that means we got AO1 squared minus O1E squared equals 2 AO2 squared minus O2D squared, right? This is saying that the power of A to O1 equals the power of A to O2, which means that A is on the radical axis of two circles, the two circles, that's the O1, O2, right? And we already know that the radical axis is perpendicular with the O1, O2, and AH is perpendicular with BC, which is in parallel with O1, O2. That means AH is perpendicular with O1, O2. So AH is a line, the radical axis contain AH, right? So we just prove this problem. Okay. This is a problem that not very difficult to think of. It's just you need to correlate it with what we learned before, the Stewart theorem. It's a really powerful theorem. You can use it everywhere. So I hope you like this video. See you in next one. Thank you.